Hello everyone. Today I'm going to talk about the embryonic stem cell research versus adult stem cell research by Robert Pandura. That's me. So there's a huge debate about this new type of research that can really help to enhance the human life as we know it. And that's due to science. Science has improved our quality of life immensely, has created new ways on how to improve our way of communication, our way of medical treatments, our way of how do we communicate with each other, such as technology, cell phones, computers, medical treatments, like I mentioned before, anything. Science is all about breaking down the barrier of what is possible, or what is basically thinking of what is known, to question about what's known, and create new solutions and new hypotheses to improve the results that are currently given. And that's how society is creating human nature. So back to embryonic stem cell research. How is science going to improve and resolve an ethical issue that a lot of researchers and scientists and politicians have been talking about for recent years? Embryonic stem cell research, right? Versus adult. So where are these cells coming from? Why are the embryonic stem cells such an issue? Well, embryonic stem cells are coming from a fertilized egg. So it could be either by vitro fertilization or when in unfortunate cases a fetus is being aborted due to a personal choice or due to a medical reason. And scientists use these cells to get specific stem cells to create a specific treatment if it's allowed. Now, these cells need to be gathered specifically, like I mentioned before. And based on those cells, specific specialized areas are being targeted. For example, a stem cells can be converted into a brain cell or a nervous cell, which is part of the brain, which is equal part of the nervous system, or a blood cell, or a tissue cell, etc. Your heart cell, anything, based on the cultivation of it. So now, this is an issue because you're killing technically a human life. But that also depends, what is a human life? Where the human life starts? That's a very important question because it keeps changing based on the person that you asked. Someone who's an atheist, for example, might think that human life starts as on the first heartbeat. Not only an atheist, but based on the experiences that I've talked to people, have shown that most of the atheists believe that, which is completely fine. That's their own thinking, that's their own opinion. So when it comes to the human begins, what is your personal thought, you might ask? So, like I mentioned before, it could be your own opinion. So, some people believe that human starts when the first heartbeat starts, beating and stuff. Some others believe when the egg is fertilized, when conception is, takes place. So it really depends, but at the end of the day, that still raises the question. It's still an ethical issue because at the end of the day, it's still a human or a developing human in a cell form that later becomes a full-grown human being. So that's why it creates this ethical issue. But then we have the adult stem cells, where you use them and you gather from an adult. So you don't have to destroy a human life for the purpose of research. So where do these adult cells come from? So you get it from your skin, you get it from your digestive system, cornea, skeletal muscle. Anywhere in an entire body, you can detect a stem cell based on that image that I'm showing you guys right now. So why weren't we using these stem cells before? What was it so specifically using embryonic? I'm gonna get more into that, but right now let's talk about more of the clinical studies that have been done in order to alleviate and prove that adult stem cells tends to be better, not just for the fact that you're not destroying a human life, but is better cost effective, and it has the potential to create a better treatment for everyone. So based on what I'm showing you guys right here, we have the allogenic hematopoietic stem cells. That was kind of hard to pronounce, but basically what that means is that you are gathering the cells from another person. So you are gathering a cell from a tissue from a different person, you're cultivating it and purifying it, and then putting it onto a different being. Now, that can have some consequences. That can create some sort of autoimmune response, that can delay the process of treatment. Therefore, you need to take some sort of treatments before apply that cell so your body can absorb it and receive it. For example, chemotherapy, which is the most common one, and then some other medications as well. Based on this research I think the research was done in Switzerland. Mr. Kuriskes, hopefully I'm pronouncing his name correctly. He was doing a clinical study on this person who was suffering from HIV. And surprisingly, due to the first treatment that I mentioned earlier, they removed a stem cell coming out of his bone marrow of someone, I'm sorry. So they used a bone marrow coming from a different person. They purified it in the treatment, and then they translated it into another person, on this person that had HIV. So after chemotherapy, so the treatment can work because it wasn't his cell, so it had to adapt to his own body. After months of treatment, the patient became HIV undetectable, which means that the blood count couldn't find the HIV virus. And that's very impressive because there's no such cure for HIV. And so far, as of this day, this patient remains HIV undetectable, which is absolutely incredible. Now, another example will be a patient with type 1 diabetes. This research was done also by a clinical study in the United States as well, which they found a stem cell in this patient, in his pancreas, and then it was converted into a cell that can produce insulin. In this case, it was also used from another patient. So this person also had to go through a process that can help its body to retain this cell. As you can see, there is a pattern there where you can see how embryonic stem cells and adult stem cells, they tend to be different. So we can talk about the differentiation of embryonic and adult. Embryonic, you have the differentiation into any cell type, which is the main primitive cell. It can be mass produced, super easy. Large numbers can be harvested from embryos, but then again, you're killing a human life, depending on your definition. It may cause immune rejection. That's something that I didn't talk about earlier. It can, as a stem cell, a primitive cell, it's technically a tumor cell because it's primitive. There's no way to control it. So you have to make sure that you're controlling the cell in order to target a specific location. And then obviously it's an ethical controversy. It's basically what the main conversation is about. So now the adult stem cells, also known as multi or pluripotent cells, which basically also known as adult stem cells. They are easier to target because they're specifically coming for a specific part of the body. Like I mentioned earlier, it could be from your heart, it could be from your skin. Now, it's a very limited numbers to isolate these cells because you basically have to harvest it from an individual. It's less likely to cause immune rejection. That's where I'm going to get into later moment, which is more of an autologous cell, which comes from your own body. So there's no autoimmune rejection. And it's also less likely to form tumors, which is a big plus on that. So based on all of this, is adult stem cells the answer for stem cell therapy? However, in the United States, still limited funding due to political issues. This was mentioned also by Daniel Fox. He was talking about how it was lifted by the Obama administration when it came to embryonic stem cells. But when it came to adult stem cells, the funding was very limited. So companies had to gather their own money in order to form their own research. Now, when it comes to adult stem cells, it's the most cost-effective treatment compared to embryonic stem cell research. When it comes to embryonic stem cell research, it could be $100,000, $200,000 just for a treatment. When it comes to adult stem cell treatments, it could be about 1/4 of the entire cost. So it's a lot cheaper to apply and implement onto patients. This was also provided by Mr. Mantell in the clinical trials in his article. So he talked about how it's more cost effective. Now, when it comes to embryonic stem cells, pharmaceutical companies can patent these cells, making it even more expensive. But they cannot patent adult stem cells because they come from your own body, so they don't have rights in order to own them. They can manipulate your own cells, but they can't own them because it's your own cells. When it comes to embryonic, they can because they have no technically illegal value because there's no one signing for them. However, when it comes to adult stem cells, better ways to deliver that treatment needs to be created. That's the main issue. As of right now, a lot of scientists are using more of the allogenic types, which comes from another individual. But if scientists were to use more of a autologous treatment, will be easier to apply. However, it takes more time because you have to gather that cells from a specific person, and that takes time. So I know in the future they're going to create better treatments and better research, and that way it's going to be better for all of us in case God forbid we get more treatments that are for autoimmune diseases or diseases that are not curable as of this century or as of this moment. So yeah, that was my presentation for adult stem cells and embryonic stem cell research. Thank you.